Question number 4, we have to find the number of points of discontinuity of the function, and the function is given as. Okay, so let's try to rephrase this function. So this function is equal to, and here for the first value of the function, for x is less than equal to minus 3, it's modulus of x plus 3. And we know that for the modulus function, when x is less than equal to 0, the value is negative x. So it as it's less than equal to minus 3, so this is negative x. So this one can be written as negative x plus 3 when x is less than equal to negative 3. Okay, for the second value of the function, that is minus 2x, this is when x is greater than minus 3 but less than 3, and 6x plus 2 when x is greater than or equal to 3. Now, this function is defined on the points minus 3 and 3. So let's say this is negative 3 and we have these intervals. So for less than negative 3 or equal to negative 3, the value of the function is negative x plus 3. And between negative 3 and 3, it's negative 2x. And for greater than equal to 3, it's 6x plus 2. So let's try to check the continuity of these uh, function. Let's try to check the continuity of this function on points negative 3 and 3. So first one is at x is equal to negative 3. So at x is equal to negative 3, when the value of the function is negative 3, it's negative of x plus 2. So this is negative, and x is negative 3 plus 3, which gives me 6. Let's find out the left hand limit. So left hand limit is equal to limit. This is x tends to negative 3 negative, and for less than 3, the value of the function is negative x plus 1. So this is limit x tends to negative 3 minus, which is negative x plus 1. Okay. So the left hand limit means this is the function, and let's assume here that x is equal to a small value h less than negative 3, and when x tends to 0, h tends to 0. So this is as x tends to 0, h tends to 0. So I can write this limit now in terms of h, that is when limit h tends to 0, this is negative, and x is negative 3 negative h plus 3, which gives me limit h tends to 0. So this is 3 plus h plus 3, and taking the limit, putting h is equal to 3, which gives me the value 6. Let's find out the right hand limit. So right hand limit is x tends to 3 plus, okay, this is negative 3. So when the value of the function, when a value of the x is greater than negative 3, the function is negative 2x. So this is limit x tends to minus e plus negative 2x, and I can write it as x tends to negative 3 plus negative 2 into x. Now x here, let x be a small value h greater than minus 3. So here as x tends to negative 3, h tends to 0. So this limit can be written as limit h tends to 0. And this is now negative 2x is this 3 plus h, which gives me limit h tends to 0. This is 6 plus, or this is 6 negative 2h, and when I take the limit, taking the limit for h is equal to 0, this value is equal to 6. So this function is continuous as value of the function as negative 3 is equal to left hand limit is equal to right hand limit is equal to 6. So x is equal to negative 3 is a point of continuity. Now let's check the continuity of this function at x is equal to 3. So when f x is equal to 3, function is defined at x is equal to 3, function is defined as 6x plus 2. So this is 6x plus 2, which gives me 6 into 3 plus 2 is equal to 20. Now let's find out the left hand limit. So left hand limit is limit x tends to 3 negative f of x. And for value of x less than 3, x when x is less than 3, the function is negative 2x. So this is limit x tends to 3. This is 2x. Okay, sorry, this is negative 2x. And now let's assume that let x is equal to a small value h less in 3, and here as x tends to 3, h tends to 0. So this function is now defined for limit h tends to 0, which is minus 2x is 3 minus h, which gives me limit h tends to 0. This is negative 6 plus 2x, and taking the limit, putting h is equal to 0 here gives me negative 6. Okay, obviously this function is not continuous because the left hand limit is not equal to the value of the function, but let's find out. Let me show you how to find out the right hand limit for the function. So when the value of the x is greater than 3, the value of the function is defined as 6x plus 2. So this is 6x plus 2, and let's say let x is equal to a small value greater than 3, and as x tends to 3, h tends to 0. Okay, now this limit has been changed to h. So limit h tends to 0 gives me 6 into 3 plus h plus 2, which gives us limit h tends to 0. So this is 6 3, that is 18 plus 6h plus 2. And if I put h is equal to 0 here, which gives me 20. Now the value of the function at 3 is not equal to left hand limit, and left hand limit is not equal to the right hand limit. So value of the function is equal to right hand limit, but left hand limit is not equal to right hand limit. So x is equal to 3 is a point of this continuity. So it's asked in the question how many points of discontinuity are there. So there is one point, that is x is equal to this. So function is discontinuous at x is equal to 3. Moving on to question number 5.